Welcome to 3 Steps to Sketch. In this video, we'll graph the basic cosecant equation, y equals -3 cosecant pi x. So here's our template and our grid. And we should see this equation is in that general form, y equals a cosecant bx. There's no shifting going on, and that's how we know we can use this more basic template. So let's dive in. Step 1 is to find our companion equation and the essential information. So our companion equation is going to be the exact same equation. We'll simply replace the cosecant function with its reciprocal function, sine. So that'll be y equals -3 sine of pi x. So we're basically going to graph this companion equation and then transform it into its reciprocal form, the cosecant equation that we want. If you aren't familiar with graphing sine equations, I'm going to post some links in the video description, so be sure to check those out and get really confident with your sine graphing and then come back to cosecant. All right, so let's analyze this sine equation. We see that a, which is the coefficient in front of sine, is -3. So take the absolute value of that. The amplitude of the sine function should be 3. That's distance from midline to maximum or midline to minimum. The negative tells us that our pattern for our sine graph is actually going to be reflected over the x-axis. So I like to put a star here. That's really the most relevant in step 2. And I don't want to forget about that when we get there. So the star will help trigger the memory. Hey, that's reflected. Okay, b is the coefficient in front of x, so that's pi. It tells us we should have pi, or 3.14 cycles that happen between 0 and 2 pi. And we can also use it to find the period. We use 2 pi divided by b to get the period. So 2 pi divided by pi is 2. And remember, period is simply the length of a horizontal cycle. Now that we have all that information organized, let's choose how to label our axes. So we're really most concerned about our horizontal axis, and with the 3 steps to sketch method, we do this very intentionally. Take the period and divide by 4. So 2 divided by 4, we should count by 1/2 when labeling the horizontal axis. And what this does is it ensures in step 2, when we plot our companion pattern, that each of these points starts by aligning with each horizontal tick mark. It just makes for a really nice clean graph. For our vertical axis, we'll usually use 1. And so let's take a moment and label these axes. So horizontally, we're counting by 1/2. So 1/2, 1, 3/2, 2, 5/2, 3, 7/2, 4. And I'm going to pause and label the negative side of this. Same values, just negative. So here's the full horizontal axis labeled. And let's label our vertical axis, counting by 1s. All right, so we're all set up with our companion equation. Before we move on to step 2, I like to find the asymptotes equation for our cosecant graph. Now, there's a really easy way to do this, and I'll post some detailed videos that go into depth on this later. But for now, it's enough to know, take the inputs of your cosecant function, so pi x in this case, and set them equal to the asymptotes of the parent function y equals cosecant x. So those happen at 0 plus pi k. And then we'll solve for x. So again, let's take the inputs of the cosecant function and set equal to 0 plus pi k. Then solve for x. So we're going to divide the whole equation by pi. And let's write our final asymptotes equation over in the template. So we'll have x equals 0 plus 1k, or just plus k. Now k here is an integer. And depending on what integer you plug in, you get a different asymptote on your final graph. And I like doing this at the front of the work when we're still doing all the analysis, because it's a great way to feel confident as we're getting our final graph that we have everything in the right place. So we should be expecting asymptotes. Let's do a few. Let k equal 0. We should expect an asymptote at x equals 0, or on the y-axis. If you let k equal 1, we should have 1 at x equals 1. K 2, we should have 1 at x equals 2. K is -1 at x equals -1. So this is a pretty simplistic equation, actually. You could see it represented as just x equals k, but it's a really nice trick to have up your sleeve to find and concisely represent all the asymptotes of your cosecant graph. Okay, so now we've done a lot of analysis and organization to make the next two steps really easy. So step 2, we're going to plot the companion pattern. And we see this star here that reminds us that we're using the reflected sine pattern. So starting at the origin for the base pattern, we know that we'll go from an x-intercept at the origin to a minimum, to another x-intercept, to a maximum, and then we'll repeat. All right, so let's plot this. And I'm going to use light blue. Remember, we're plotting this lightly. This is our companion equation, not our final graph. So do this lightly. So we have our x-intercept that's at the origin. We go next to a minimum that happens at the first horizontal tick mark to the right, and look to A to find the y-coordinates value. So our minimum happens at 1/2, -3. Come back to the next horizontal tick mark for an x-intercept. And then a maximum happens at the next horizontal tick mark, so at 3/2, and you get the y-coordinate taking the opposite value of A, so the y-coordinate is 3. And then you would start a repeat, a new cycle, would have another x-intercept at 2. So here we've graphed the companion equation, and I'm just doing this lightly, again in my light blue here, to show you that we've essentially graphed a reasonably advanced sine equation, y equals -3 sine of pi x. So now we can do step 3, recip, sketch, and repeat. So recip, this is where we're changing our companion equation key points into our cosecant equation points. These are the points we actually want to graph. So let's start with the x-intercepts from our companion equation. Those original x-intercepts turn into vertical asymptotes. So let's go ahead and mark those on our graph. We see here's the asymptote we predicted would happen at x equals 0. Here's the one that would happen at x equals 1. And I won't mark it in green, but the next cycle will happen at x equals 2. All right, so next, our minimum from our companion equation will turn into a relative or a local maximum for our cosecant graph, whereas our maximum will turn into a local minimum of our cosecant graph. So when we sketch those in, they look like this. And we only really have a little room here because that -3 really stretched us out here. That's a vertical stretch. Okay, so here you see we have one cycle of our graph, y equals -3 cosecant pi x. And now I'll use purple to show a few more cycles. We're simply repeating this pattern over and over again for as many cycles as we need. Okay, so here's another vertical asymptote. That's when k is 2. Here's another curve that has a local or relative maximum. And remember, we say local or relative maximum simply because in this area, this is the highest y-coordinate. It's not the absolute maximum, but in this small area, we have a local or relative maximum. We have another vertical asymptote and another part of the curve that has a local or relative minimum. And we can go ahead and put another asymptote here at x equals 4. So now let's work the pattern in the other direction. So we're just alternating these curves that have the local minimum and the local maximum. And make sure you're still working with the asymptotes equation, double checking, substituting in different values of k to get these different vertical asymptotes. Okay, it makes it really, really nice to have that option to double check. All right, so here are 4 cycles of our graph. Hopefully this helps you feel confident in graphing these unshifted cosecant graphs using 3 steps to sketch. I'm going to post a bunch more examples worked out, and in the video description I'll also include links if you're interested in graphing any of the other trig functions. I'll post links to playlists for those as well. Thanks for watching.